Hey, what's up, guys? Chung here again. So today I want to talk about another LeetCode problem here, number 670, maximum swap. So the problem description is fairly straightforward. Basically, you're given like an integer, and you can only swap two digits at once, at most once, and then you need to return the possible maximum number after swapping, right? For example, this one here, 2736. So the maximum number after one swapping will be 7236. Basically, you swap 7 with 2, right? And in case of this one, in case all the numbers they are like from the sorted from biggest to the lowest. In this case, it's already the biggest number possible, so there's no point of swapping it. In that case, you simply just return the number itself, right? So how should we approach this kind of this problem, right? I think one basically we need to uh, do some observations here and also write some of the samples here. So I'm gonna just create like some random samples here for 3, let's say 5, 3, 8, 2, 3, 8. So well, actually it's too big for me because it says the number is like 10 to the 8 power of 8. So Uh, anyway, I'm just assuming this is still a valid number here. I'm just using this kind of long numbers to better explain this approach here. So if you watch closely, right? So basically, what do we want to do here, right? We want to swap this number. In this case, so what's the best the optimal solution here, right? It's if you watch it closely, so we have 9 here at the beginning, right? And then we have 8. 8 is still 8, right? There's no, but later on there's no there's 8 here. Then it's this 6, right? So when we meet 6 here, uh, we'll be swapping. So when we add 6, so what should we swap? We need to swap with this 8? No, right? That 8. Basically, we need to swap these two numbers to uh, to get the maximum number, right? After swapping. Then okay, so I think the first observation will be so for number, right? Let's say for number, regardless of its values, we need to we need to know its index, right? But in our case, let's say for 8, they're like they're like how many 8s? 1, 2, 3, right? So which index is the one we care? The last index, right? For in this case, right? We have two indexes of 8 after 6, but what we need is the last index. Right. So that's the first observation. We keep with that in mind, basically we'll be creating like a dictionary or a hash map, whatever you want to call it. And to that dictionary will be like the key will be the number itself, right? How about the value? The value will be the last index of this number, right? Last, last index. Okay. So first we're gonna have this one hash map here to store each number and its last index, right? And then with this hash map created, how can we use this, right? Then we're gonna loop through all the numbers, all the each number here, and we're gonna use like the greedy uh, a greedy algorithm here or greedy idea here, whatever you want to call it. So the greedy idea here is that for each numbers, we always try it from the biggest digit, which is 9, right? Until this number itself, until the number itself plus 1, until the 6 plus 1 in this case. Basically, for each of the for each of the for each of the try here, right? Basically, we try all the numbers bigger than the current index, a current bigger than the current number from maximum to the lowest. That's why we try to greedy. We are hoping to find the maximum as the biggest one as early as possible, right? And then the reason we stop at the current number plus one is because if it's the same as the current numbers, there's no point of swapping it, right? And if it's smaller, of course, there's no point of swapping it. So that's why the range will be from the biggest to the current one and plus one, right? And then what do we check? We check each number within this range. What's the index of that number, right? So if that index is after the last index, if that last index is after the current index, right? If this index is after this current index, then we know, okay, we find a way of swapping it, right? If this index is before this, we know, okay, it's before that, so we cannot swap it. For example, this is 9, 9, and 6, and for example, we are processing 6 here, right? We start from 9 here, and we see, okay, 9 is in the dictionary, but the index is 2, right? Sorry, is 1. The last index of 9 is 1. 1 is smaller than 3, so we cannot swap with that. So we have to find, and then we finish 9 here, and then we'll check 8, and then we see 8. Okay, we see 8 is in the hash map, right? And the last index of 8 is this one, somewhere like 10. I think it's 12 or 13. Yeah, 12 is greater than 3, and then we know, okay, this is the number we want to swap. And when we find that, we can simply stop there because it only allows one swap, right? Cool. I think that's basically the idea of this solution here. It's a greedy method, a greedy idea here of always try to find the maximum number after this number, after the current number as early as possible. Okay, so now for coding, we first, like I said, we need to have a dictionary to store all the numbers last index, right? We can look at last index. I will just call it last index. What's gonna be that? So simply just like the number, right? The number of the uh, number of index, right? For we just do a enumerate, okay? So that we can get both the numbers and the index, right? So that's how we do find the last index, because if we find this number later on, same numbers, since this is like integer, so this key will be updated with the later index. And since we're looping from left to right, we're making sure once we finish loopings for each number, this index will always be the last one, right? For this number. Okay, so that's that. And then okay, another thing is in order to swap these numbers, right? We need to convert this number to a string, to a list of string, right? Otherwise, we cannot just do the swap, right? Swapping. To convert it, we can either do like a mathematical way, which is like we divide this number, with like we do a that div mod, right? With this number with 10, right? And every time we get the remainder and we add it to the string to the list until until the this number becomes 0, right? But we have a simpler way of doing this. It's just to do a conversion, right? Basically, I'll just use that. Um, so we're gonna have a numbers list. We simply do a first we convert this number into a string. We just use a string function here, and then we convert this string to a list, right? Pretty simple. Yeah, I think that's that. Yeah, and then like I said, we just simply loop the current loop the integer, loop the number here, I uh, n, right? For not enumerate enumerate num, right? And okay, then for each numbers here, we loop through 9 to the current number plus 1, right? So in order to do that, so here, right, we have to for I for for k for digit in range, we have to do a 9 plot to this number, but this number like it's yeah, that's the oh no, sorry, it should be the list here, right? So we loop through the list here, and but since we're trying to do a range from this 9 to this n here, but remember current right now this n is a string, right? Because we convert this integer to a string. But what we want is we want this one to be integer. So then we have to do a little bit of conversion here. I know it's a bit annoying here, but let's do it. So for each of the numbers here, we just do a uh, convert it into an integer for right something like this. We just for each of the integer character in this string here, we just convert into an integer, and then we convert it to a list. So now this number will be an integer here, right? And then we're looping through 9 to here, right? Since the end point is exclusive, that's happens to just satisfy our requirements here, right? So we don't want to include this n. We want to stop it be, before n, which means all the numbers is greater than n, right? So then for that, right? So for each of the digits here, we want to check if this digit's index is greater than the current index, right? So we do what? We do a last index, right? Last index. Since this like this number, this digit it's possible could be not uh, exist in this index here, right? So we can simply do this like if the we can either use a get, right, to do that, or we can simply do a simple check here. If d is in, right, in the last index, right, we do a simple check, and last index dot d, right, then we know the d is there is greater than the current index, right? If that's the case, we know okay, we find our the numbers we need to swap. We just simply swap these two numbers. Uh, the first number is the number is index I, and the second one will be the nums list uh, of the last index D here, right? And then we just simply do a swap with this shortcut, uh, shorter version line of in Python without using a temporary variables. And then we simply return, right? We simply just, I mean, we can, if we break here, you know, in Python, if you break in the nested loop, it will only break for the loop where you're in right now. It won't break the outer loop here. That's the basically that's how the break works in Python. So we can simply return here, right? We can simply return the so in order to stop these things, we need to do a return here because we cannot break the whole loop and return what do we return here. Okay, so we already have it. So all we need to do uh, now is just to convert this string a list back to the integer, right? So we do int, right? And then we do what? We do join, right? We join all this number back to but remember here, right? Since the join here, joins is expecting a string type. So and now we have all the int type in this array. So we have to convert them back to the string. Again, I know it's not very intuitive way, but I'll just finish what I'm doing here. Digit, right? For digit in nums list. Okay. So once again, we convert all the digits, all the integer in this num list back to the string, and then we join them back, and then in the end we convert them into integer, right? And how about now? Don't forget about example two here, right? So if none of those happens, which means we never find like a bigger numbers that has like a later index, we simply return the number itself, right? Okay, I think that should do it. Let's run it. Uh, yeah, sorry. Hmm? Oh, sorry. Yeah, okay. Sorry, I need to create this list first, and then I need to use this list to do the enumerate here. All right, accepted. Let's try submit it. Cool. Yeah, so uh yeah, it works. Basically, the idea here is just to keep the last index of this array here, not array of this a list of numbers for each numbers, and then we'll do a greedy search here. A greedy search, we search all the numbers uh, greater than its current digits. If there's an index for that number which is later bigger than the current index, and then we know we find a result. We just swap them. Uh, cool. I think that's it for this problem. Actually, I want to maybe talk a bit more about this problem because at the beginning I didn't come up with these solutions. What I did was I uh, I figured out so I figured out we need to swap the current the ones the this number with the current the biggest number, right, with the latest index, right. So what I did what I ended up doing was I created like a dictionary, of course, to store all the indexes, and then I use a priority queue. I use a priority queue to store the current biggest numbers, right? And then every time when I see a numbers here, I check, okay, so if this number is not the same as the first one in the priority queue, because that priority queue always give me the current biggest number, right? And then if we see like index here, sorry, if I see a number here, and if it's the same as the current priority queue's first element, I just uh, I just remove the index for that number, right? That's how I keep this index this like priority queue. Basically, I have one priority queue and one dictionary for the counters. The not counters. The dictionary stores all the number each numbers the indexes in that dictionary. I didn't thought about all I need was the last index. That's why I store all the indexes for these numbers for the current number into that dictionary. And every time when I see this like a number here there, I compare with the priority queue. If it's the same, I just remove the first index from that priority queue from that dictionary because the when I when I add the index, I add it from left to right, right? So now when I see this number, it's safe to remove the first index in that dictionary, and then when I see and then if that dictionary the list is empty, I just remove I just pop. Basically, I just do a heap pop from the priority queue. Then we know, okay, we have seen all the appearances for that numbers. And then when I see until we see a number that still has it's not same as a priority queue, the first element, then we know, okay, we need to swap this number's index with the last index in that dictionary. It's kind of a long implementation, but it worked. It's not as simple as neat as this one, but it's anyway. It's just my some thought. And okay, cool guys. I think that's it for this problem. I thank you so much for watching the videos, and I hope see you guys soon. Bye bye.